Hello, everyone. I'm Dhaval. I'm the Generative AI Specialist SA. And today I am going to show how to deploy multiple fine-tuned foundation models on SageMaker at scale with high performance cost effectively. Let's dive in. So there are various reasons why you might want to fine-tune or customize your foundation models. Now, you want to increase the accuracy and adapt your models based on your business domain, or customer data, or a specific downstream task, and make them highly personalized. Now, there are several methods to customizing your foundation models. First is the prompt engineering, which is carefully crafting and iterating on the prompts provided to the foundation models to steer their outputs in their desired direction. Or you have retrieval augmented generation, which basically relies on retrieving the relevant text from the large corpus and aid the text generation. Now, the retrieval happens first, and then the retrieved texts are used to condition the model's text generation, allows generating very high quality, factually considered text by grounding the generations in retrieved evidence. Now, the other type is the fine-tuning or adapting a pre-trained foundation model on a specific downstream task or for a specific data set. And this allows tailoring the model to a particular domain by updating the model weights on the new data set. Makes the model more specialized for the target task while retaining the general capability. So that's the advantage of this approach. Or you can rely on training from scratch the entire foundation model, call it as pre-training, and so that basically is training on the large language model on a data set from random initialized weights rather than pre-training. And so allows fully optimizing the model for a specific domain without inherited biases from other data sets, but requires a large amount of task-specific data and compute power. And so sometimes it becomes cost prohibitive. So in this session, we are going to focus on how to deploy the customized, fine-tuned foundation models at scale with high performance cost effectively. So many applications in natural language processing or generative AI, specifically related to the large language models, rely on adapting one large-scale pre-trained language model to multiple downstream applications. Such adaptation is usually done via fine-tuning, which updates all the parameters of the pre-trained model. The major downside of fine-tuning all the parameters is the new model contains many parameters as in the original model. For example, fine-tuning of 175 billion as an example and deploying multiple independent instances of this huge model or fine-tuned models, each with 175 billion parameters, is prohibitively expensive from training and inference perspective. And so parameter efficient fine-tuning technique, which we also call it as PEFT, offers an effective solution by reducing the number of fine-tuning parameters and memory usage while achieving almost comparable performance to full fine-tuning. So low rank adaptation, or we call it as LoRA in short, is a type of parameter-efficient fine-tuning approaches for fine-tuning your models. LoRA freezes the pre-trained model weights and injects the trainable rank decomposition matrices into each layer of the transformer architecture, greatly reducing the number of trainable parameters for the downstream tasks. Compared to 175 billion fine-tuned model, LoRA can reduce the number of trainable parameters by 10,000 times and the GPU memory requirement by 3 times without additional inference overhead latency. Now, this is a great approach to adopt when you are looking to deploy tens to hundreds of highly customized models at scale cost effectively. And I'll show you how to deploy multiple LoRa adapters, fine-tuned models at scale cost effectively on SageMaker. All right, so let's dive into the code. So in this screen, what I'm showing is serving LoRa-based Llama 2 7 billion adapters with high performance on SageMaker. The use case is, let's you have, you want to use Llama 2 7 billion chat model as a base model. And then you want to fine-tune your Llama 2 7 billion models using LoRa-based adapter technique. And you ended up having 3 LoRa-based adapters specifically for specific language. So you want to serve, you want to use only one copy of the base model while you have language-specific LoRa adapters fine-tuned, and then you want to use that deployment to power your business applications for different language. In this case, I'm going to show you 3 language adapters that you have fine-tuned, which is Russian language, Spanish, and French. And let's see how you can deploy these 3 adapter models attached to the base model and run the inference at scale on SageMaker. All right, so what we are going to use is the large model inference container, which is a pre-built, highly optimized, compatible container with Amazon SageMaker for inference for running foundation models at scale. And large model inference container basically has a full integration with open source frameworks, libraries that offers high performance for running foundation models. And one of these open source frameworks that we integrate with is called as VLLM. VLLM is an open source fast serving framework, includes the fast model server for running the large language models and running the LoRa-based adapters at scale. So here is the serving stack or a runtime serving stack of large model inference container on SageMaker. So on top we have the front end server, which is based on DGL serving, which is based on Java, and then we have different backends, including the VLLM backend and the large model inference distributed backend. And the VLLM backend and the LMI, just in short, is it uses underlying VLLM open source backend for doing additional optimizations in terms of serving the foundation models and serving these LoRa-based adapters at scale. VLLM under the hood uses open source libraries for optimizing for optimal LoRa-based adapter serving, including LoRA, which is another open source framework for specifically LoRa-based serving, and Punica, which is another open source framework that offers CUDA adapter optimizations or CUDA kernel optimizations for adapter models. So combined together, VLLM offers a full integrated solution, which is again integrated with SageMaker's large model inference container, which we are going to use in this session. Okay, there are several advantages of using the VLLM and the LoRA approach. The number one is when you have multiple fine-tuned LoRa adapters and running against the base model, what you end up generally as a traditional approach is to merge these adapter models with the base model and then run the inference. But when you have more adapters and you want to serve that at scale, you can't possibly rely on the approach of merging all of these adapters with the base model, because it's just going to increase the number of copies of the base model, and it's eventually going to increase the number of the amount of memory required to load these multiple instances of the base models, and it becomes cost prohibitive, and it also becomes a very non-performing solution from the inference standpoint. So the approach that LoRA takes, and eventually it was also offered as a feature in the large model inference container of SageMaker, is unmerged LoRA inference. Basically what that means is these adapters are not merged at all and are kept decoupled from the base model, the first place, and the inference or the forward pass is run independently for both the adapter models and the base models, and the final output is sent back to the caller. That we call it as unmerged LoRa-based adapter inference. And then if you have multiple different types of adapters to use, just like in this case, you have 3 adapters, and multiple different types of requests for different types of adapters may come concurrently at the same time. And you don't want to have multiple copies of the base model because it will increase the memory consumption. So you can use this unmerged inference along with the dynamic heterogeneous batching. So you might want to batch these different inference requests coming for different adapters, which you call it heterogeneous, and then you want to patch them together to increase the throughput and to get the best price performance. And there are added additional optimizations that LoRa brings on the table, including offloading these adapter models if it exceeds the GPU's high bandwidth memory. It offers an ability to offload some of the adapters that are not used or based on the least recently used algorithm, offload them into the CPU host memory, and then whenever they are required, it brings them back into the GPU's working memory. Here is the quick diagrammatic representation of how the dynamic adapter loading happens, or the offloading to the CPU happens. The adapters could be loaded actively on the GPU high bandwidth memory, and then they might get offloaded to the CPU memory if they are not being used, or there's a memory pressure of loading more active adapters into the memory, and you have to make some space to accommodate them. Then the least recently used adapters may get offloaded to the CPU and eventually eventually the external storage if required. But the LoRa offers that feature of CPU offloading and then reloading from CPU to the GPU high bandwidth memory based on least recently used algorithm out of the box. You don't have to write a single line of code. It's just there out of the box. So let's go back to our code. Another open source framework called Putica. It offers CUDA adapter kernel optimizations so that you can reduce the response times, reduce the GPU memory I/O operations, and it also optimizes the matrix multiplication operations for different LoRa-based requests in a batch. And combined together, all these features combined together offers high performance in terms of reduced response times and high throughput on SageMaker. Okay, so we are going to use a large model instance container called LMI container, and we are going to use VLLM backend in this case, as I'm showing in this diagram, and then we are going to serve multiple adapter models for inference. Okay, so here are some of the code typical code to create the session for SageMaker. We're going to skip it. Board of 3 clients, very easy. All right, here's very, very important step that I want to highlight here. So what we're going to do is you can upload the adapter models, model weights, and the model artifacts to Amazon S3. and the way how to package or bin pack these adapter models. There's a specific structure that you have to follow in terms of the folder structure. So what we're going to do is first we are going to use the base model as Llama 2 7 billion chat with the data type of FP16, which requires two bytes per parameter to store a single parameter, and then we are going to use 3 fine-tuned adapter models. In this case, we have an adapter model fine-tuned for Russian language, Spanish, and French. And so if you go to the Hugging Face website and check out their adapter configuration, there is a file called as adapter_config.json. I'll give a lot of great information, metadata information about the adapter and how was it fine-tuned, and specifically the rank of the adapter, which is extremely important parameter to configure when we configure our SageMaker endpoint. All right. So we'll come back to this file. So we'll go back to our code. So we have 3 LoRa fine-tuned adapters and 1 base model. All right. The first step is to download these adapters, LoRa-based adapters, and convert that into, or bin pack into a model.tar.gz with a specific folder structure. And the folder structure is you have a model directory, and then you have a specific adapters folder, and within the adapters folder, you have multiple different adapters, artifacts downloaded from Hugging Face, and then you have a common serving.properties, which is a configuration file for configuring the large model inference container, LMI container, which you can configure for different for the performance reasons. And then you can also bring your own inference script called as model.py, and you can write pre-processing or post-processing code that you want to write. And then get going. The serving.properties and model.py, they're optional. You can also specify the parameters that you specify in serving.properties in the environment variable as well, and go from there. So first step is to download the 3 LoRa fine-tuned adapters and create a directory called as LoRa multi-adapter, and within that we create a folder called as adapters, and then we download one by one all the 3 adapters from Hugging Face. Once we do that, we then tar.gz the folder and then upload it on S3. And if you want to see how the folder structure looks like here, I'm showing it here in my studio notebook, and you can see here the adapters folder is created. Within the adapters, you have the Spanish adapter with ES, FR for French, RU for Russian, and then individual adapter directory has all the artifacts needed, including adapter_config.json, which is a metadata file for the adapter, and then the safe tensors file is basically the actual model weights of the adapter. And then there are a lot of other configuration files, like including tokenizer.json and so on and so forth, which is definitely essential for serving these models for inference. And so remember, very important, within the adapters directory, the name of the folder, like here in this case, ES, FR, and RU, will become your adapter names. And that is required when you invoke the endpoint. So keep that in mind. The name of the adapter is required to invoke the SageMaker inference endpoint. Basically, that is needed to invoke the respective adapter for your inference request at scale. All right. So now that we have created the model.tar.gz, we have let's upload that in S3. And so here is the code for uploading the model.tar.gz with this predefined structure where we have multiple adapters been packed. Now, you can also choose to not tar.gz and just upload the raw artifacts on in the S3 location in an uncompressed format too. That is also supported. All right, so let's go over to the next step. The next step is to set the configuration parameters using environment variables. Remember, I said that there are two ways to configure LMI container. Either use serving.properties and make it as a part of the model.tar.gz, or you can configure as part of the environment variables when you create the SageMaker model object. So we are going to follow the second approach here. There are specific LoRa specific fine-tunables or configuration parameters that you can set. The first very important parameter is the enable_LoRa, option_enable_LoRa, which you have to set it to true. By default is false when you want the LoRa adapters serving in SageMaker. Okay, and then the next one is max LoRa's. This determines the maximum number of LoRa adapters that you can run at run at once, and so it serves as allocating more GPU memory for those adapters. Default is 4. You can increase it if you are loading more than 4 adapters and you want them to be served concurrently. All right, and then you have max LoRa rank, which basically is the rank of these LoRa adapters, the maximum rank of these LoRa adapters. And remember, I showed you adapter_config.json file. Let's go there. Let's see the rank of one of these adapter models, which in this case is Russian fine-tuned adapter model. The rank is specified by the attribute called as R in this file, which is 64, sorry. And so if you go back and check the rank for all other LoRa adapters, you will see the rank is same, which is 64. So we're going to set that to 64, by the way, in our configuration. And then you have additional LoRa configuration that basically is going to drive the allocation of the memory. We're not going to go into those details. The more details are available here. If you're curious, to learn about them, then I have attached the link to. I have attached the link to the extended fine-tunables or configuration parameters, and it just walks through these parameters, default values, what does that mean, and when should you set them, gives you best practices, so feel free to refer to them. Let's come back. All right, so what we're going to do is we're going to create a SageMaker model object. For that, you need to retrieve the image URI, container image URI of large model inference container for SageMaker. In this case, it's the V27 version of the large model inference container for deep speed. So we retrieve the URI, and then we set these configuration parameters as part of the environment variable of the model creation. In this case, we specify the base model. The base model, which is Llama 2 7 billion in this case, with FP16. You can specify the Hugging Face model ID here in the option_model_ID, or you can upload your own base model in the S3 location and provide the S3 location here. And then you can specify how many shards you want for that base model. In this case, we have set it to max. That means use the maximum GPU devices available in the host, which is what we are going to default to right now. And so basically, whatever instance type that we select is going to fully utilize all of the devices, GPU devices in that host, and shard it across. We are going to use the backend as VLLM, as I showed you earlier. So the rolling batch is set to VLLM, which basically means that you want to use VLLM, and then there are additional parameters like batch size or continuous batch size, the data type for the model, the base model, which is FP16. And as I referred to you earlier, you need to enable the LoRa-based serving by setting this enable_LoRa to true. And we set the max LoRa rank to 64. Remember, we saw the config adapter JSON file, and we saw the rank of these adapter models was 64. So we're going to set that same here. And then we go from there. A max CPU LoRa is a very important parameter. Now, max CPU LoRa is a configuration defines maximum number of LoRa adapters to cache in the CPU memory as well. And so all others will be then evicted to the external disk. So you might want to set this to a specific number so that you don't have to swap out to the disk, and that all these adapters and that the instance that you select has the required amount of the CPU memory to hold these adapters in the host memory. So in this case, we're going to set it to 4 because the number of adapters that we are going to take it up here in this example is just 3. So 4 is more than enough. And then we get going with the creation of the model. So we create the model object of SageMaker with the image, with the environment variable, and the S3 location where our adapters artifacts are stored or uploaded. Okay, and then we create a SageMaker endpoint config. And basically, you select the instance type as G5X large, which has one GPU, A10G GPU, with 24 gigabytes of high bandwidth memory per device, and there's only one device, by the way. So the overall, we have only 24 gigabyte of the high bandwidth memory. And we can easily fit 7 billion with FP16 base model, single copy in a single device of A10G. So you shouldn't have any code out of memory errors or such. So we choose to select only X large. We can also select 4X large, the 12X large, which has 4 GPUs, or you feel free to use other instance types. In that case, you would have to increase. You can also increase the number of model copies and increase the performance that way. We're going to use G5XL in this case. Okay. And then you create the endpoint with the model and the endpoint config we created with create endpoint API of Bodo 3. By the way, the whole code that I'm showing, you can also do it with SageMaker Python SDK, and there are different constructs for that too. And you can also use Bodo 3 as I'm showing here. So, all right, and then we wait for the endpoint creation. Once the endpoint is created, you call invoke_endpoint API or invoke endpoint API of SageMaker using Bodo 3. And then you have 2 attributes within the JSON file or the request JSON. One is the inputs, which basically bears the prompts for the inference, and the adapters, which basically you can specify the name of the adapters that you want to invoke for that specific prompt. Now you can batch these prompts and invoke in one go, or you can have multiple different requests coming into your container at a different time interval. And remember, there's a heterogeneous dynamic batching also implemented on the server side, which will take care of batching them together and running the inference in batch to maximize the throughput and give you the best price performance. So that will still happen on the server side, and you get all these goodies in the inference optimization from the inference optimization perspective. So in this case, we are going to invoke the Spanish adapter. So you can see here the prompt is in Spanish, and we invoke that. You can also change the adapter to let's say RU, which is Russian, or you can also use French, you have to adjust the prompt accordingly, and then invoke the endpoint. And so you can see here it's a three-step process. Upload your adapter models on S3 in a specific in a specific folder structure. You can upload the compressed or uncompressed artifacts on S3. You create a SageMaker model object with the with the LMI container URI, and set the right environment variables or configuration variables, and then create a model object, create an endpoint config object, and select your instance type. You can also configure the auto-scaling policy, and then you create the endpoint and invoke the endpoint. It's a 4-step process, and you're good to go. And we'll take care of loading the adapters dynamically, and implementing the dynamic batching, and make sure that they are not merged, and that you can get the best out of the price performance, and serve these adapter-based fine-tuned models at scale. You can also auto-scale them using multiple instances behind the inference endpoint, and that way you can serve hundreds to thousands of LoRa-based adapters at scale for your production use cases. Okay, so here's an example notebook that I was going through. You can scan this, and you can directly go to my example notebook and give it a try. And don't forget, you can also scale this solution by attaching an auto-scaling policy, and you can scale out to hundreds of LoRa-based adapters serving at scale on SageMaker. I hope this session was useful. I'll see you in the next session. Thank you for watching.